In this video, we're going to look at a different t-test called a paired t-test, or sometimes it's called a repeated measures t-test. And so you'll see my data file here. This is a study set up to where, let's say, we want to look to see how people drive, the number of errors they make, and maybe in a closed course while driving, while either listening to music, which would kind of be our control condition, or driving while talking on the phone. And so the numbers here represent the number of errors that they made. You'll notice here is each of the drivers. So we have 14 drivers, and they went through the course twice, and then the number of errors recorded. Now, for this to be the study to be conducted correctly, right? They shouldn't all drive through the course first with music and then driving by the phone. That we did counterbalancing here. Some drove while talking on the phone first and then driving with music second, and vice versa. So we assume that that's what had taken place within this particular study. So we're looking here at the number of errors that they made, and we're looking at a comparison between the two conditions to see, okay, is there a difference? Is there a significant difference in the number of errors made when you're talking on the phone versus just driving while listening to music? So we would go up here to t-test, and paired samples t-test is how it's listed in JASP, and again in some others it might be called repeated measures t-test or dependent t-test sometimes as well. And so we're pairing up our two variables, and so we're not pairing up the driver, but we're pairing up the driving with music and driving with the phone. And just as an aside, notice here that in the data that it was brought up, it has this little symbol over here. That means that it was taken in as ordinal data, and I want it to take it as a scale variable, as an interval or a ratio scale, to see it in that way. So I click on here, that little tab right there, and I change it to scale, and I do it for this one as well. Okay, so now I go back to my paired samples t-test. I combine these two together, and I put them over. Those are my paired variables that I have. And in looking through, as always, I want an effect size. I like to have the descriptives as well. The descriptives plots can be helpful too. And so I've got my information here. I'm going to get rid of this so it's not confusing to people. And so we've got our main results here. And so you'll see the t statistic, and it's a negative t statistic because we're taking driving with music minus driving with phone. And so you remember that number of errors there were smaller as compared to here, and you can see that down here as well. And then we've got the t value. So this is telling us that the mean difference between those two situations is a little over 3 times larger than what we'd expect by chance. Here's our degrees of freedom. We had 14 participants, so 14 minus 1 gives us a 13. Here's our p-value, 0.006. That's a probability that we would get a t this large just by chance, which is pretty remote. And then here's our Cohen's d, our effect size. That effect size is we would consider that to be a large effect for this set of data. So down here we've got our descriptives, and we see that on average, when they drove with music, they made less errors as compared to when they were driving on the phone, and we can say it was a statistically significant difference between those two. And you'll see here as well, we've got our descriptive plots here with our standard error bars and the means between the two. So how would this look in terms of writing up the results? So first, let's copy and paste our results here. So we're going to copy this, paste it over here in the Word document. So we've got our data listed here, and then here's our write-up. So participants made significantly less driving errors while driving while listening to music. And then you'll note I've got this mean and standard deviation, which you see down here. compared to when they drove while talking on the phone. And we've got our mean and standard deviation. Here is what that they use for that. And then we've got our shorthand. Remember our statistical shorthand that we write things up. So this was a t-test. It was 13 degrees of freedom that we see right here. The t-value is listed right here. Remember, we tend to usually just go two decimal places with that. We've got our p-value that's listed here. And then we've got our D, our Cohen's D, that's listed here. And we put all of those in, and we've got our results for this particular paired samples t-test.